In this video, we are going to discuss about the topic surface areas and volumes, that is chapter 13. We all are familiar with the shapes of the solids: cuboid, cube, cylinder, cone, sphere and hemisphere. Cuboid, we know cuboid has 4 lateral faces, one base and one top. It has length, breadth and height. Cube is also have 4 lateral faces, one base and one top. It has only side. For the cube, all the sides are equal. Then cylinder has 3 faces, one curved surface, one base and one top. Base and top are the shapes of circles. Then cone, it has 2 faces, one curved face and one base. Base is in the shape of circle. Then sphere is like a ball, for example. Then hemisphere, it is half of the sphere. For example, we can say the half portion of a lemon is in the shape of hemisphere, or the bowls we are using, that all are in the shape of hemisphere. Now we are going to discuss about the formula to find out the curved surface area or lateral surface area, total surface area and volume. The difference between curved surface area and total surface area is, in curved surface area we are going to consider only the lateral faces or curved surface. But for the total surface area, we are considering lateral surface or curved surface and base and top. The formula: cuboid LSA 2 into L plus B into H, TSA 2 into LB plus BH plus HL, volume LBH. Cube LSA 4A square, TSA 6A square, volume A cube. Cylinder CSA 2 pi RH, TSA 2 pi R into R plus H, volume pi R square H, where R is the radius and H is the height. Cone CSA pi RL, TSA pi R into R plus L, volume 1 by 3 pi R square H, where R is the radius, H is the height, L is the slant height. And there is one formula to find out slant height also. The formula is L square equal to R square plus H square. Find out this value and find the square root of it. We will get what is L. Then sphere has curved surface area and total surface area. Both are same because it has no separate base and top. The formula is 4 pi R square. Volume is 4 by 3 pi R cube. Hemisphere CSA 2 pi R square, TSA 3 pi R square, volume 2 by 3 pi R cube. A toy is in the form of a cone of radius 3.5 cm mounted on a hemisphere of same radius. The total height of the toy is 15.5 cm. Find the total surface area of the toy. So here I have drawn the figure of the toy. A cone is mounted on a hemisphere. So there is a hemisphere and a cone is on it. The radius of the hemisphere is given 3.5 centimeter. So the height of this hemispherical portion is 3.5 centimeter. It is given the total height of the toy is 15.5 centimeter. So the height of this conical part is 15.5 minus 3.5, that is equal to 12 centimeter. Our question is to find the total surface area of the toy. So that is equal to CSA of hemisphere plus CSA of cone. The formula to find CSA of hemisphere is 2 pi r square. CSA of cone is pi rl. Here radius of hemisphere 3.5 centimeter. Radius of cone also 3.5 centimeter. Slant height of cone is missing. So let us find out the slant height of the cone first. The formula is L square equal to R square plus H square. That is equal to 3.5 square plus 12 square. That is equal to 12.5 plus 144. That is equal to 156.25. L equal to root of 156.25. Here we can apply the division method to find the square root. So we will get L equal to 12.5 centimeter. So TSA equal to 2 into 22 by 7 into 3.5 into 3.5 plus 22 by 7 into 3.5 into 12.5. That is equal to 77 plus 137.5. That is equal to 214.5 centimeter square. A cubical block of side 7 centimeter surmounted by a hemisphere. What is the greatest diameter of the hemisphere can have? Find the surface area of the solid. So here I have drawn the figure. There is a cubical block and a hemisphere is surmounted on it. So the first question is, what is the greatest diameter the hemisphere can have? You see, this is our hemisphere and this portion is the diameter of the hemisphere. So the greatest diameter the hemisphere can have, that is equal to side of the cubical block, that is 7 centimeter. So the diameter is 7 centimeter, therefore the radius is 7 by 2, 3.5 centimeter. Now the second question is, find the surface area of the solid. So the solid is a cubical block and a hemisphere is surmounted. So we need to find out the area of this cubical block and the area of hemisphere. You see, the 5 faces is visible in this solid, but the top portion I have drawn it separately here. In that top portion, a circular part is taken for this hemisphere. So total surface area of cube minus area of circle, that is only needed for this cubical portion. Then you can see the curved surface area of this hemisphere also visible. So total surface area of the solid equal to total surface area of the cube minus area of circle plus CSA of hemisphere. Why we have subtracted this area of circle here? Because in the top portion a circular portion is not visible in this solid. So it is not needed. That is why we have subtracted area of this circle in this case. So that is equal to 6a square minus pi r square plus 2 pi r square. That is equal to 6a square plus pi r square. So this is a general formula we are using in these type of questions. So here we can give the values. So we get that is equal to 6 into 7 into 7 plus 22 by 7 into 3.5 into 3.5. That is equal to 294 plus 38.5. That is equal to 332.5 centimeter square. One more question. A hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. Determine the surface area of the remaining solid. Here also the idea is same. There is a cubical block. Here in this case a hemisphere is kept on the cubical block. In the second case a hemisphere is keeping what it is keeping inside the cubical block. A hemispherical depression is cut out. That means there is forming a depression of hemisphere. So here also we can use the same formula to find out the total surface area. The formula is 6a square plus pi r square. Here the diameter is L. We know the diameter and side of the cubical block both are same. So side also will be L. So we can give that is equal to 6L square plus pi into L by 2 whole square. That is equal to 6L square plus pi L square by 4. Cross multiplying we get 24L square plus pi L square by 4. L square by 4 we can take outside. We get there is remaining pi plus 24. A medicine capsule is in the shape of a cylinder with 2 hemispheres stuck to each of its ends. The length of the entire capsule is 14 millimeter and the diameter of the capsule is 5 millimeter. Find its surface area. So here is given the figure of the capsule. I have drawn it again here. Now you can see a cylindrical portion is there. Then 2 hemispheres are on the both ends. Here the total length of the capsule is given 14 millimeter. Here it is given diameter of the capsule is 5 millimeter. So this length is 5 millimeter. So the radius is 2.5 millimeter. So we can say the height of this hemispherical portion is 2.5 millimeter. Here also one hemisphere. So there also the height of the hemispherical portion is 2.5 millimeter. The total length is 14 millimeter. Both the ends 5 millimeter is for the hemispheres. So the length of this cylindrical portion is 14 minus 5, that is equal to 9 millimeter. So we can say the radius of hemisphere is 2.5 millimeter. Radius of cylinder is 2.5 millimeter. Height of cylinder is 9 millimeter. The question is find the total surface area of the capsule. Surface area of the capsule equal to surface area of the cylinder plus 2 into curved surface area of hemisphere. That is equal to 2 pi rh plus 2 into 2 pi r square. That is equal to 2 into 22 by 7 into 2.5 into 9 plus 2 into 22 by 7 into 2.5 into 2.5. That is equal to 990 by 7 plus 550 by 7. That is equal to 1540 by 7 equal to 220 millimeter square. A tent is in the shape of a cylinder surmounted by a conical top. If the height and the diameter of the cylindrical part are 2.1 meter and 4 meter respectively, and the slant height of the top is 2.8 meter, find the area of the canvas used for making the tent. Also find the cost of the canvas of the tent at the rate of rupees 500 per meter square. Note that the base of the tent will not be covered with canvas. So here I have drawn the figure. It is saying that a tent is in the shape of a cylinder surmounted by a conical top. So there is a cylinder and a cone. Here it is given the height and diameter of the cylinder are 2.1 meter and 4 meter. So height of the cylindrical portion is 2.1 meter. Diameter of the cylindrical portion is 4 meter. So radius is 2 meter. Since the diameter of cylinder is 4 meter, diameter of cone also 4 meter. So the radius of cone also 2 meter. And it is given the slant height of the cone is 2.8 meter. First we need to find out the area of the canvas used for making this tent. So we need to add the CSA of cylinder and CSA of cone. Let us find out it separately. CSA of cylinder equal to 2 pi RH, that is equal to 2 into 22 by 7 into 2 into 2.1, that is equal to 26.4 meter square. CSA of cone pi RL, that is equal to 22 by 7 into 2 into 2.8, that is equal to 17.6 meter square. So total area of the canvas equal to 26.4 plus 17.6, that is equal to 44 meter square. Here in the question it is given cost of the canvas is rupees 500 per meter square. Therefore total cost equal to 44 into 500, that is equal to rupees 22,000. From a solid cylinder whose height is 2.4 centimeter and diameter 1.4 centimeter, a conical cavity of the same height and the same diameter is hollowed out. Find the total surface area of the remaining solid to the nearest centimeter square. So there is a solid cylinder with the diameter 1.4 centimeter and height 2.4 centimeter. From this solid cylinder, a conical cavity is hollowed out. So it is hollowed out, therefore there is formed a new shape, that is the shape of a cone. So now the new solid is, from outside it is looking like a cylinder, but inside there is a conical portion also. The question is, find the total surface area of the remaining solid. So to find out the total surface area of the solid, we need to find out the curved surface area of cylinder, area of base, that is circle, and curved surface area of cone. Here the radius of cylinder is 0.7 centimeter and height is 2.4 centimeter. Therefore, radius of cone also 0.7 centimeter and height 2.4 centimeter. Here, slant height of cone is not given. So, let us find out it first. The formula is L square equal to R square plus H square. That is equal to 0.7 square plus 2.4 square. That is equal to 0.49 plus 5.76. That is equal to 6.25. L equal to root of 6.25. That is equal to 2.5 centimeter. So we have got the slant height 2.5 centimeter. CSE of cone equal to pi RL, that is equal to 22 by 7 into 0.7 into 2.5, that is equal to 5.5 centimeter square. CSE of cylinder equal to 2 pi RH, that is equal to 2 into 22 by 7 into 0.7 into 2.4, that is equal to 10.56 centimeter square. Area of base, that is circle, that is equal to pi r square, that is equal to 22 by 7 into 0.7 into 0.7, that is equal to 1.54 centimeter square. Therefore, area of the remaining solid equal to CSE of cone plus CSE of cylinder plus area of base, that is equal to 5.5 plus 10.56 plus 1.54, that is equal to 17.6 centimeter square. Here it is given, find the area to the nearest centimeter square. So let us round it, we get that is equal to 18 centimeter square. A wooden article was made by scooping out a hemisphere from each end of the solid cylinder as shown in figure. If the height of the cylinder is 10 centimeter and its base is of radius 3.5 centimeter, find the total surface area of the article. So here is given the figure of the article. It is a cylinder and two hemispheres are scooping out from each end. So we can see in this article the curved surface part of the cylinder and two hemispherical shapes on both ends. So to find the total surface area of this article, we need to find out the curved surface area of the cylinder and curved surface area of two hemispheres. CSE of cylinder equal to 2 pi RH, that is 2 into 22 by 7 into 3.5 into 10. Here radius is 3.5 centimeter and height is 10 centimeter. So we get CSE of cylinder to 20 centimeter square. CSE of hemisphere 2 pi r square, that is equal to 2 into 22 by 7 into 3.5 into 3.5, that is equal to 77 centimeter square. Total surface area of the article equal to CSE of cylinder plus CSE of two hemispheres, that is equal to 220 plus 2 into 77, that is equal to 220 plus 154, that is equal to 374 centimeter square.